So today we will talk about MergeSort, and there are 4 topics in my agenda today. So first, MergeSort visualization. Second, divide and conquer technique. Third, MergeSort runtime, and finally Python code walkthrough. Okay, first, let's go to the MergeSort visualization. So what is MergeSort? Imagine if you have an array of 10 elements and values inside the arrays is random. Then we will divide the array in half, and then we keep splitting until element of the arrays is equal 1, as we can see in step 4 and 5. So if the array is equal 1, it means, what does this mean? This means it's sorted already. The array tree is sorted already because a single array is sorted by itself. Then after we divide all the arrays into 1, then we need to conquer it by solve a subproblem. By solve the subproblem is, for example, 1 and 5, which one is smallest? So 4 is smallest, it's in front, and 5 is the larger value, so it's at the back. 7 and 4 is the smallest, so it's in front, and then 7 is at the back. Then we merge again, 3 and 1.5 and 1 5. So 1 come first, and then 3, and then 5. This is really quick in sorting. Then the same thing for this guy. So it's 4, 7, 10, and then for 6, 9, and then 1, 3, 5, we start to sort. So we get 1, 3, 5, 6, and 9. Then we do the same thing on the right hand side. Start with 2, start with 4. 2 is the smallest, so we have 2 here. Then we update the index. 8 and 4 is the smallest, so 4 go first, and then we update 7 and 8, so 7 smallest. Then 8 and 10, 8 is smaller. Then 10, then we do the same thing again. So 1 and 2, 1 is the smallest, 1 first, update 1. 3 and 2 is the smallest, update the right hand side metric. 4 and 3 is the smallest, update the left hand side. 5 and 4 first, update. 5 and 7, 5 come first, then update. 6 and 7, so 6 coming first, then update. 9 and 7 come first, then update. 9 and 8 first, then update. 9 and 10, 9 and then 10. There we have it, the sorted algorithm. Then we go on to the concept part. So the concept part is the divide and conquer technique. So basically, first we have the original problem. Then we divide original problem into a subproblem. Let's say in this case it's subproblem 1 and subproblem 2. And then we conquer the subproblem 1 by solving this subproblem. So it solves subproblem 1. And then we conquer the subproblem 2. So then we receive a solved subproblem 2. Then we combine these 2 subproblems together. Finally, we get a solved original problem. MergeSort worst case runtime. So MergeSort worst case runtime is a log n. And if we can see on the flowchart here, so if the array is size 6, the bubble sorts would take around 36 iteration in runtime, and then for the MergeSort it would be around 18. But if the value is get larger and larger, the array size is really large, then the bubble sort would take forever compared to MergeSort, which take less time. Okay, that's all for the concept part. Now we will get to the Python walkthrough on how to implement MergeSort. Let's get to it. So now we get to the walkthrough on MergeSort using Python code walkthrough. Alright, MergeSort is a recursive algorithm. So we will learn about recursive algorithm today on how to use the recursive algorithm on MergeSort. Okay, let's get started. So first we write a function called MergeSort, and then this MergeSort take an array. If length of an array is greater than 1, then we do the following. Middle index equal np int 64 length array over 2.0. We want to keep divide smaller and smaller, and then the left hand side array, or the array that we slide on the left, would be merge, and then we call the merge sort again. Middle index right hand side equal merge sort array middle index the entire until the end. Then array equal merge, then you merge an array left and right. Okay, so then we return array. So this is the merge sort, but let's see, are we finishing this yet? Well, we don't know what is merge yet, so let's construct the merge function. Okay, let's import numpy first. I forgot it. Alright, cool. Then we define merge. Merge is we merge left and right array together. Then we merge left and right array together. Then we determine the size of the left hand side array LHS and size of the right hand side of the array which is length RHS. Okay, and then we set the index left hand side equals 0 because we haven't determined which elements in the left or right have a larger values, and then we sort it from there. Okay, you see index right hand side equals 0. Then merge array equal np dot array empty. Now while index right hand side plus index right hand side less than or equal size of the left hand side plus size of the right hand side -2, then we stop the sorting algorithm because it finished. The reason that we -2 because the index of Python will always start with 0. Okay, if index LHS less than size of the left hand side and index of right hand side less than size of the right hand side, there are two cases. The left hand side array index left hand side, if this element is less than right hand side index side, so the next element of the array would be merge array left hand side index left hand side index, and then we update the index left hand side equal index left hand side +1. Okay, now we see the other case. We do the same thing. Since the left hand side is greater than or equal right hand side, so we change the merge array. So we update the merge array on the other side. Then merge array right hand side index right hand side. Then we update the right hand side index. Okay, so now if index left hand side greater than or equal size of the left hand side already, then we don't have to compare the two arrays anymore, so we can just merge the remaining right hand side array to the merged array. Return merge array, and then if index array greater than or equal size right hand side, then merge array equal append merge array left hand side index left hand side, then the rest. Then we return merge array. Alright, let's try this out. Array A size, let's say 30, and then array PA range, array size 30 plus 1 np random dot seed 1 np random dot shuffle array A in the original problem array A. Okay, then we call MergeSort array A 1 2 3 4 5 6 7 8 9 10 11 12 13. Yep, and then we got a MergeSort, and here it is. This is the MergeSort. As we can see, the main important part of the MergeSort is the divide part or the recursion function. The key concept of MergeSort is recurrent functions. As you can see, once we call MergeSort, we always keep dividing left and right, left and right, left and right, until the array of the smallest problem is 1, and then we start to merge it back together, as I teach in the MergeSort visualize in the first part. If you like to check the concept out, please go to the beginning of the video. Alright, and then that's it about the Python code. If you like, please share, subscribe. Thank you so much.